All right, ladies and gentlemen, welcome back to Math 1800 Pre-Calculus at Wayne State University. My name is Resh Mahaber, and today we will talk about composition of functions. So what are composition of functions? Well, forget mathematics for a second, and let's just talk about, and of course, if you don't know what a function is, you need to go back and look at my beginning video in section 2.1, I think it was, where we talked about functions, their domains, how they interact with one another, and just all in all, what we use them for, okay, to give it some sort of purpose, right? So it's just a machine, right? So sometimes functions are not things that are effective by themselves. They need to be strung together to become part of one giant effectiveness. So I'll give you a prime example. A car. A car is a machine, a giant machine, right? But inside that machine, it's composed of many other little machines: carburetors, pistons heads, fuel injectors, anti-lock brakes, electrical systems, computers itself, right? So there's many different combination of functions, and they combine together to give one singular output. So that's kind of what we're going to talk about today, is these combinations of different kinds of functions and what they do. And it starts with basic functions, but then we'll be stringing them together, okay? So composition of functions are not much different than anything else that we do, but you just got to get used to some new notation, okay? So here's some new notation for you. So for a composition of functions, f plus g of x, obviously, what do you think that is? Well, it's a giant addition sign. It probably means this, when this is exactly what it means, is that if you have two functions, f of x and g of x, this is a short-term way of writing add the f function and the g function together. Notice the input remain the same. So we're basically saying that if we had some guy that's composed of the f function, plugging it into the f function first and the g function, adding it together, would be the exact same thing as adding it into this guy. Fairly simple. What do you think this guy means? Well, just like addition, if you have a minus sign, we're subtracting two functions. So this is fairly simple. How about this one? Okay, notice there's nothing in between here. Obviously, when there's nothing in between something, it implies multiplication. So we're multiplying these two together. Very simple. And last but not least, this guy. This means take the f function and divide it by the g function. Obviously, the g function can't be 0, otherwise you'd be dividing by 0. So it's fairly simple to actually figure this kind of thing out. All right. So let me just do a quick example real quick, just so you can kind of get a feel of what's going on here. Let's let f of x equal 5x plus 6 and g of x equal 2x minus 1. Well, then obviously, if I wanted to find out what the composition that f and g have, if we were to add them together, right, in that fashion, that means that I'm adding the f function. I'm just going to go to the definition. Go to the definition. Okay, the f function is going to get added to the g function. Now notice these are general functions, so we're just going to add both formulae together. 2x minus 1, and then this simplifies down. 7x plus 5. So you'll notice that adding, so the idea is that this is what it all simplifies down to. And it's more efficient and more effective, okay? Many different fields actually have these kind of capabilities, like especially like in computer sciences and the computer syntax and languaging. Many different computer languages. If you're a computer programmer, you'll be using a lot of what's called classes or object-oriented program, which basically is the same kind of thing. It's stringing together other functions that may exist to make your own custom functions. That's where the big money is, by the way, if you can actually start creating those. All right. So these are the four basic ones, but there's one more guy, and this is really the guy that's a new beginning for most of us. Okay. There is a little bit of notation, and sometimes we're not trying to add two functions together to get this third thing. Sometimes we want to take the output of one function, and then take that and shove it into something else. Okay, so I'll give you an example. Maybe I want to take the output that a conveyor belt that drags, I don't know, coal, right? So the conveyor belt's one function, call it f, and it drags coal. So let me draw you a picture. Here's the coal input that you dig out of some mine. We'll call it x. F is the conveyor belt. It drags it up a hill, okay, and drops that off into a giant bin. Then the giant bin dumps over into a giant fire or flame that's going on to create some sort of heat. Well, the fire or flame, notice it uses the output of the coal bin from the last guy to be the input of the new function. Well, that is the G function. Right? So this thing is shoved into your G function, but what comes out? The same way that we insert x into the f function comes out f of x, the insert here is f of x, right? So the thing that comes out is G, but what's going to be in here is going to be, where's my little red pen at? Is going to be f of x. So what this means is you start with x and you shove x inside of f and then shove f inside of the thing that comes out of there into G, and then what you come out with is this final product. And this might be heat, this might be a train, a choo-choo train that goes around and around and around and around, right? But in the end of the day, we compose two little functions in order, our conveyor belt, which was f, and then this is the coal, and the coal gets dumped off into a bucket, and then the bucket turns, which is the G function, into the fire, and then the fire burns it, and boom, we got energy. Okay, but it all started with composing these in a string, right, one right after the other. Well, this is called the composition of two functions, and the way we abbreviate this, right, is going to be, so you notice the way it's oriented, G's on the outside, F's on the inside. We orient this, and the notation is G little circle F of x. That's why with multiplication we have nothing in between here, because we don't want to confuse multiplication and composition. Composition means shove one function inside of the other function. Okay, so i.e., so what this means is that f composed with the G of x, all that implies is that we're going to shove the G function into the f function, and likewise G composed with f of x is the same thing. Shove the f function into the G function. It's fairly simple. It really is. You just got to understand stuff, right? So let's do a couple examples, and then we'll hopefully get to some nitty-gritty stuff, right? So this is your new piece of the puzzle today. So here's one I want you to attempt. Pause the video, attempt it, and then after you pause the video, unpause it to see the work. I want you, so write this down. Let f of x, and I always encourage you to pause the video and try problems out, because that's how you'll get the most out of it. X plus 5, okay? And let's let g of x equal x cubed, okay? This is what I want you to find, okay? Or, yeah, this is what I want you to find. Find f composed with g of x, okay? And then, here's what I want you to find. That's A. And B, I want you to find f composed with g of 11. And this is where I'm going to do some really cool stuff of 11, not x. You just did that one. And I'm going to show you some cool stuff here. So what do we do for this guy? Start with the definition, shove g of x into f of x. Well, what is g of x? Good news. We know g of x is x cubed. So that really means I'm plugging x cubed into the f function, right? And the f function says I'm going to take the cube root of whatever the heck I plug in there plus 5. What am I plugging in here? Well, it's x cubed. Done and done. So this ends up meaning that I end up having cube root of x cubed plus 5. It's very, very simple. It's like it's not hard at all. Okay? So I want you to look at this. Okay? It says find f composed with g of 11. I know I put two arrows here, but let's just focus on one arrow. Well, didn't we just create the f composed function? So this says that f composed with g of x is the same as doing this function. So if I want to find f composed with g of 11, option 1 would be to find the composition function and then plug in 11. So f composed with g of 11 is the same as f composed with g of 11. So at first thing that crapola, I did it. I did it already. I wasn't trying to go there. So this is going to be the cube root of x of 11 cubed plus 5. Oh boy, it's about to be some big numbers. Anybody know what 11 cubed is? Holy moly guacamole. Let's put some numbers in. 11 times 11 is 121 times 11 is 121, 121, 1331. That's interesting. Plus 6 more, plus 5 more is going to give me 1336 cube rooted, and I'm pretty sure that's my answer. Now, this is a really, really damn big number, but it's okay though. This is going to prove my point. So sometimes you need scratch work, get it out. All right, this is option 1 of doing it. So you actually go through the work to construct your composition function and then plug in your number. Or option 2 is you go back to the definition. G composed of 11 of 1. So you first got to figure out the inside. It's like order of operations. Figure out the inside. So you go to the side, G of 11. Scrap paper will be your friend here, guys. You still got to figure out what 11 cubed is, which I think we just did. It's 131. So now we have to figure out what F of 1331 is. Now this F should be in black. Let me erase all this. This is 1331. All right. F. And we're trying to figure out what this does in the F function. Well, the F function says shove in 1331, and then what are we going to do to it? We're going to take the cube root of 5, which is the cube root of 1336. Now, why did I do these both ways? Notice we got the same answer. Because in order to do this, you either got to construct the function and then plug it in, or you go add it directly, do some side work, come back, plug it in, and then evaluate. So in either effect, you should end up with the same answer, but you have to choose one and stick with it. It's fairly simple. So either you're creating the general form. And the reason why I think both of these are very, very relevant is because sometimes you will get asked just to create the function. We're not interested in inputs and outputs. If we're just interested in one specific example, it might not be worth the time to go through and construct all this. Just go ahead and grind out your inputs and outputs. But let's say you had a guy that says, hey, find F composed of G of 11, and then 7, and then 6, and then 5. It might be easier to do this and then plug each one of these singularly and get outputs out. So this is what I mean by you're in a course now that pre-calculus is one of those courses where it requires thought of process and to actually see the shortest way of doing things. So composition of functions really, really, really are not all that bad. All right, let's upgrade a little bit. Here's one that is a blast from the past. Let's let F, so this is example 2, f of x equal x minus 6 over x plus 1. And let's let g of x equal x squared plus 2. This is actually one that I would encourage you to stop the video and actually grind through it. I want you to find and simplify f composed with g of 2. I want you to divide that by f of 2. Now, this is not that hard to do. But what you're going to have to do is do the pieces first. And if you notice, this is the exact same thing that we did when we evaluated functions in chapter 1 and in the beginning of chapter 2. We figured out that piece and then this piece, and then we'll divide the two. So let's figure out piece 1 and then piece 2. Piece 1, that's f composed with g of 2. Now ask yourself, is it really worth shoving the g function into this and doing it in general? Right? Is it really worth figuring out what f composed with g of x is just to shove into? That's a lot of work. I don't feel like doing it. They didn't ask me for multiple inputs, so I'm just going to do this guy by itself. So let's see, what is g of 2? Can I do it in my head? That's 2 squared is 4 plus 2 is 6. So I'm going to get, when I do g of 2, right, order of operations, do the innermost stuff first. This is just 6. Okay, if you need scrap paper, you should go for it, but you should always encourage yourself to do mental work and then check it with scrap paper. This is how you grow your mental capabilities. Now plug in 6. You get 6. Switch some colors on you. And I need to plug 6 into my f function. The f function says, oh, that worked out pretty nice. This is just going to be 0 over 7, which is just 0. So what's the conclusion? F composed with g of 2 equals 0. Let's figure out what f of 2 is. That's the second piece, right? F of 2 is, and some of you are already like, well, isn't this enough? Can't I stop? If you're paying attention to things, you probably could stop because this is your numerator, right? That means this is 0. Unless this thing is 0 down here, you can pretty much conclude your answer is going to be 0. 2 minus 6 over 2 plus 1 equals negative 4 over 3. All right, now let's finally figure it out. So this equals 0 over negative 4 over 3. You could do whatever multiplying reciprocals, but anything over a number is still going to get 0 over any number is still going to give you 0. That's the answer this is going to be. It's really cut and dry. No more, no less. All right, one last one, and this is the one I will collect from you in class tomorrow, or if you could do it, you want to send me an email to get your answer. By all means, I'd encourage it. Here's the example. Let f of x equal the square root of x minus 2, and g of x equal x squared minus x minus 4. I want you to find this guy, and simplify, obviously. I want you to find f of 3. And after you do it, I want you to multiply it by 3. Look at that. And then I want you to divide that quantity by g composed with f of 3. Okay? Let me know what you get. All right, this is Rush Mahaber talking about compositions functions. I know this is a shorter one, but I feel like this is actually an easier topic. Next time to come, we will talk about inverse functions, which relies heavily on compositions and a little bit of more preliminary understanding. So once again, if you want to do something you've never done, you're going to have to go somewhere you've never been and make yourself uncomfortable. Talk with each other, and if you got any questions, send me emails, and I look forward to seeing you on the next video. All right, adios.